Today, I'll be talking about kites. Kites were crucial in the history of aerodynamics. Kites are not just pieces of paper, wood, and fabric, and they're not just depending on your hope for it to fly, or the winds, or sheer willpower. They do abide to the rules of aerodynamics a normal aircraft would abide to. Specifically, today I'll be talking about a kite simulator made by Glenn Research Group by NASA. Kites are an excellent way for students to gain a feel for aerodynamic forces because kites are affected by the four forces that generally affect any aircraft: lift, drag, weight, and thrust. Thrust in this case is substituted with wing. Kites come in many shapes and sizes. The forces which act on the kite are the same for all kites. The similarity in forces allowed the Wright brothers to test their theories of flight by flying their aircraft as kites from 1900 to 19. You might be wondering, why did they choose flights, or kites to be exact, to fly or make their researches? And that's because they're cheap, they're easy, and they're mostly crash-proof. They're very inexpensive, so they don't need engines, they don't need fancy materials, just wood, fabric, and a whole lot of patience. They're also very low risk, so if your kite design fails, just make a new one. And you can just tweak the designs quickly and fly it over and over and over again until you get the right results. They also used it because it proved their theories without a pilot. Because, pilots, every time you want to make a new experiment, that would cost a lot of human life. So, kites started small and they failed often, but they did the risky work first. So, humble beginnings for the next big thing in flight, I guess. So, my simulator today is about the Glenn research paper made by NASA. It's a simulator that generally helps you understand the physics and the maths and also the aerodynamics in which a kite flies. You can choose from different types of kites. You can change the size, the shape, the materials even of the kite design. And you can also choose the values of different variables, such as the altitude, so the height you want your kite to fly in, and the wind speed and the design. So you can see new flight characteristics in each design that you choose. The program also tells you if your design is stable. So if your kite is too wide or maybe it's too long, it would tell you that, hey, your kite won't fly. And also computes a prediction of how high your kite will fly depending on your input variables. So let's dive in. So once you go into the site, this is the first screen that you would see. It might take a few minutes to load, and it's better working on desktop. Trust me, I've learned that the hard way. But it would eventually pop up and it would work. This is the main site, and it discusses kite simulators and how each of these values affect how your kite flies. So I'll start you off with the basics. On the left hand of the screen, you'd find the zoom button. So this actually just zooms in and zooms out of your kite design. The scale actually is there to control these vectors. And these vectors, as you can see, control or not control, they show you the lift, they show you the drag on your kite, they show you the weight, and they show you the wind speed. And you can actually see something really interesting, which we learned in our lectures, which is that wind is in the same relative direction in which drag is, and lift is perpendicular on drag and wind. So that's a really interesting fact. The next thing you want to see is you can change the metrics of the input that you are in. So from inches, if you choose metric, you'd go to centimeters. If you choose imperial, you'd be in inches and foot. And you can see that here as well, and in all of other tabs, which we'll get into later. You can also select the view. So this is the front view of your kite. It shows you the height, the width, and the center of pressure and the center of gravity. And I personally like this view better because it's really cool when you change the shapes of your kite, so you can actually see it. So that's a delta kite. You can see it has a swept back wings, which generally make it easier to fly. You have a sled kite, kind of looks like a hexagon, dare I say. You have the box kite, which you can zoom out a little bit to see it better. You can see that it has a hole in the middle. There is the winged box kite, which is just a mixture of the box kite and the wing kite, or kind of the sled kite. You have the twin trap kite, and you have the tumbleweed kite, which is personally my favorite because it looks like a tumbleweed. So we'll go back to the shapes later. You also have the side view. The side view actually, so let me just go over here. So when you press the trim tab, it changes you back to the side view. And it really shows you the vectors, like I discussed, the lift, the drag, the weight, and the wind vectors more accurately. In the fly tab, you can see your kite in the field view, which there's a small person here flying the kite, and changes in altitude, for example, would show you how high your kite would fly. So you can see that with this altitude, so 34 feet, and a wind speed of 50 foot per second, the kite flew at a certain level, and it changed in the y direction. So we'll also discuss these in a bit, but I think that's also pretty cool. Also, you can actually see the kite not only on Earth, on an average day on Earth, you can change it to Mars, an average day on Mars, which I don't, I guess I see why they added that, because you want to see how, because Mars has a different center of gravity. So if you're interested in that type of thing, you can change between Earth and Mars. And something cool also is that it's very easy to correct your mistakes per se in this simulator. Just press the reset button and it would reset all your settings. Maybe you entered the wrong height, you chose the wrong material, and we would see that by actually getting a pop-up message here that says unstable trim, unstable altitude, your kite can't fly. So you can just press the reset button for it to reset, just like it did right now. So here we're talking about different types and shapes of kites. So you have here the delta kite, which is kind of more side-swept wings, which makes it really easy to maneuver and easier to fly. And then we can see that we're moving on to the sled kite, in which the sled kite is actually bigger in size, which means it needs less air or less wind to be exact to fly. Makes it better in stable wind. As you can see here that we have some dimensions, and basically these dimensions are variables that you can input. So this would be height, height number 1, 2, width number 1, and width number 2. And shortly I'm going to insert some values, and we're going to see how that directly affects the sled kites on our left side. So after entering a height or a certain amount of height, you can see a pop-up message right here that says unstable design, which is a feature in the simulator in which helps you to choose the right dimensions for your kite. So if your kite is too long or too wide or too narrow or too short, it wouldn't be able to fly. And the website or the simulator would tell you that. Right here, we can see that we can change the material in which a kite is made out of. So there's the plastic kite, the tissue paper kite, the ripstop kite, the paper kite, the silk span, and each type of material has different characteristics in how the kite flies. Usually, lighter material don't need as much air to fly. They're pretty low maintenance, you can say, but in strong gusts of wind, they can get structural damage. So choosing the right material is really crucial for how long or how high you want your kite to fly. So as you can see, this is the second tab, which is the trim tab, and it actually controls the angle, the brittle, the knot, and the tail in which a kite flies in. These are all settings in a kite, and we're going to get into them shortly. So lift and drag are forces that are submitted, or a kite is affected by these forces, by lift and drag, as well as weight, and as well as the wind speed, which we cannot see because it's too strong here because of the scale. So let's talk about the brittle and the knot. So the brittle and the knot are essentially the connection between a pilot, or the person flying the kite, and the kite itself. So shortening the brittle, making it short, or moving the knot lower is going to increase the angle of attack. And it would cause more lift, but also more drag. So the stall risk is too steep. So let's make the knot 10 as well. And as you can see, if you make the knot or the brittle too low, your design would be unstable because it would reach stall. Lengthening the brittle or moving the knot higher would decrease the area of attack and would cause less lift, but it would also reduce the drag. And the kite would fly faster, but it also may become unstable. Changing the tail length. So let's reset. Changing the tail length, making it longer, is going to increase the stability of your kite, because the center of the mass is going to shift downward, reducing the angle of attack. So it's going to cause less lift, but it's also going to reduce drag. A very light tail or a short tail is going to cause a higher angle of attack, but it also increases the drag. So you just have to weigh your pros and cons and how you want your kite to fly, but essentially these are all settings that you can change in the simulator. It's all about trial and error. Something I'd like to emphasize is torque. Torque is essentially a force that causes the kite to spin or rotate. And it's usually because of asymmetric forces or the asymmetric design of your kite, and it may cause unwanted spins or steering, which may be hard to control, especially in lighter kites. So you'd really want to pay attention to your torque value here whenever you change these values. So now we can move to the exciting part. We can move to the fly button. And I don't want to see how my kite flies on Mars, so I'm just going to change it to Earth. So as we mentioned, you can see here that this is the field view. So you can see a person flying your kite, and you can see it in action. We're gonna go over all these settings. So wind is the wind speed in which your the kite, it's an aircraft, so it's fine, in which your kite is flying in. And generally, lightweight kites perform best at 10 miles per hour. So let's see. This is generally how a kite would fly on a normal 10 miles per hour. Well, this is not really miles per hour, so this is miles per second. So generally that's the default wind speed. And 10 to 20 miles per hour is ideal for most kite designs. 20 miles per hour plus is going to risk a structural failure in real life, but it would also give you a message in the simulators telling you that your kite is unstable. So you really have to pay attention to that. This button right here is the altitude. So how high you want your kite to fly. So let's go back to Imperial and let's put it at about 50 foot. That didn't really change anything. So 100 foot. And let's make the wind speed a 50. You'd see that your kite is actually flying higher. So because it's a lightweight kite, and remember the shape is a diamond kite with normal default settings for a diamond kite, you'd see that at 50 foot per second, it's going to go at 100 foot in altitude. And you can change these settings depending on how you want your kite to fly or act in certain days. So a line is the string or thin cord made of cotton, nylon, silk, or wire which connects the kite to the person operating it. And a payload is just the object or the entity that's being carried by a launch vehicle. And so those are also settings that you can maneuver or change depending on how your kite design works. So the line, which is connecting the person to the kite, got shorter here. And if you want to change it back to longer, you can see that it's going to go at a higher altitude, higher Y axis. And these are all values that you can change and test out to see if it would work in real life without the risk of crashing.